one point moves in rectilinearly in one direction. So this is the path of this point, and we have to find out the first is the average velocity of the point during the time of motion, and second is the maximum velocity, and third is the time moment t0 at which the instantaneous velocity is equal to the mean velocity averaged over the first t0 second. So let's see the problems in general physics by Irodov, and also this problem solved by the animation. Now, a point moves rectilinearly in one direction as figure earlier I have shown you. The distance s traversed by the point as a function of the time t. Using the plot, the first we have to find out the average velocity of the point during the time of motion. So this average velocity we have to find out. The second is the maximum velocity, and this third is the time moment t0 at which instantaneous velocity, this one, is equal to the mean velocity averaged over the first t0 second. So this instantaneous velocity is very important part of this problem. So let's see the equation which we used to solve in this problem. This is a velocity equals to displacement by time, and this displacement equals to velocity into time. Now you see here this point is moving and moving in rectilinearly motion in one direction. Okay. So now you see this point position. This point position. Now you see this is the time t in this x direction and this distance s in this y direction. So this point position, this final position, this is the t means the 20 second. This is the 20 second, and this final position of this distance equals to 2 meters. Okay. Now we should know the average velocity. So this average velocity means the final displacement, this 2 meter minus initial displacement. This initial displacement here is 0, 0 origin. So this is also 0, and this final time minus initial time. Okay, this final time means this is the 20 second, and initial time means this is a 0. And again it is very easy. So means this 2 meter, 2 minus 0 by 20 second minus 0 second. So you can say this is the meter per second, its unit. So we can easily find out if we convert it is in the centimeter, then it is the 200 centimeter minus 0 divided by 20 minus 0. So equals to 200 by 20 equals to 10 centimeter per second. So this is our answer. But this displacement means this shortest path or shortest distance which is followed this point. So this is, and this is the displacement, and you can say this is the distance. Now here this distance is the more than the displacement. So यहाँ पे क्या होता है, ये जो point है, this point is in the initial position, और ये जो पॉइंट क्या किया, ये पॉइंट ने बहुत सा मतलब पहले इस पाथ में गया, उसके बाद इस डायरेक्शन में गया, उसके बाद इस डायरेक्शन में गया, जाके यहाँ पे पहुंच. तो दिस इज द फाइनल पोजीशन ऑफ दिस पॉइंट, एंड दिस शॉर्टेस्ट पाथ means if we join this point with this origin, then we will get the shortest path. This one. This is the shortest path. Okay. So this is the very easy problem to understand. Now हम लोग अभी नेक्स्ट प्रॉब्लम में जाएंगे. सो नेक्स्ट प्रॉब्लम में क्या हम लोग को फाइंड आउट करना है ना, मैक्सिमम वेलोसिटी. सो यहाँ पे सेम, this point is moving in rectilinearly motion. Okay. Now this is the path of this point and this is the position of this point. This position, you can say this is the point A and point B. Now this point B in X direction, this time is the, so this is the 10 second, so this is the 14 second. Okay. Now this distance, and this is the 1 meter, this is the 1 meter, so this is the 1.4 meter. So another is the, this is the 10 second. Okay. And this is the how much? This is also 0.4 meter. This one division means 0.2 meter. 0.2, 0.2. So this total is the 0.4 meter. Again, this one division means 2 seconds. This is the 2 seconds, another this is the 2 seconds. So let's see the instantaneous velocity. Instantaneous velocity means the maximum velocity, and it is equals to ds by dt, means the maximum slope. This maximum slope means this angle. This is the ds by dt. Okay. This angle is the tan theta. If this slope is the maximum, then you can say this is the maximum velocity. So यहाँ पे देखिए ये जो लाइन है, इस लाइन का जो एंगल है, ये एंगल सबसे ज्यादा है. ये जो लाइन है इस एंगल का ये जो एंगल है इसका एंगल छोटा है कंपेयर टू दिस एंगल. ऑल्सो दिस एंगल इज द स्मॉलर in compared to this angle. Also this angle. So now you see here this angle, this tan theta is the larger. So we can say this is the ds by dt. ds means this is the ds and this is the dt. Okay. So this is called the tan theta. Now this tan theta. So again, if we find out the velocity, velocity means the final displacement. Final displacement how much? This is the 1.4 meter minus 0.4 meter divided by final time means 14 second minus 10 second. So equals to 1 by 4 meter per second, or you can say this is a 25 centimeter per second. So this is our answer. So next come to the our last problem. This is called the instantaneous velocity problem. So again this point is moving. Okay. And this point is the reached their final position, and this is the path of this point. This point. So this average velocity means this slope. This slope is the average velocity slope. And instantaneous velocity should be matched with this slope. This is the tan theta. Now you see this slope not matched. Here this theta is the greater than this tan theta, this theta. Okay. Now where this slope is matched, and this is called the instantaneous velocity matched with the average velocity. Now we should know the instantaneous velocity. Now you see this instantaneous velocity means the slope ds by dt. ये देख यहाँ पे जो स्लोप है ds by dt should be matched with the average velocity slope. This slope ds by dt should be matched with this average velocity slope. सो इफ आई ड्रॉ ए डायग्राम, यहाँ पे मैं एक डायग्राम ले लेता हूँ. सो दिस इज द पाथ ऑफ द वन पॉइंट. ओके, now you can easily understand it. I draw point like this way. Now this is the point 1, this is the point 2. तो अभी हम इस पॉइंट 1 और पॉइंट 2 को जो ज्वाइन करेंगे, तो ये यहाँ पे जो टाइम और यहाँ पे हमारा डिस्प्लेसमेंट. सो दिस we can say this line, this slope is this velocity slope. Okay, means this is the S2 minus S1 divided by T2 minus T1. Again, हम लोग इसका जो डिस्टेंस थोड़ा सा कम कर लेता है. दिस इज ए 1 dash, दिस इज ए 2 dash. नाउ यू सी, इफ आई जॉइन दिस 2 point here, this is also this is S2 dash minus S1 dash divided by T2 dash minus T1 dash. अभी हम लोग ये जो दोनों पॉइंट का जो डिस्टेंस है, इस डिस्टेंस को हम धीरे धीरे जो कम करेंगे, तो मतलब इसका जो डीएस लेंगे. तो जब डीएस लेंगे, तो हम लोग जब डीएस लेंगे, सो सपोज दिस इज द डीएस, this is the ds, also this should be the dt, also this should be the dt. और यहाँ पे जो स्लोप है, मतलब इसका जो टेंजेंट, ये जो एंगल, इसके साथ जो एंगल, दिस इज द थीटा, दिस इज द स्लोप ऑफ दिस इंस्टेंटेनियस वेलोसिटी. ओके, सो ds by dt. So ds by dt, always this velocity is the tangent of this point. Here you see, now this point, this is the tangent, this is the curve, and this is the tangent. Okay, this line is the tangent. So we can say, if this angle, suppose this angle or this angle matched with this angle, ये जो angle है, ये suppose this angle is theta and also this angle is theta. Suppose this angle, maybe this is the theta 1 or this angle is the theta 1. So if this two angle is equal, this theta equals to theta. So हम लोग क्या बोल सकते हैं, यहाँ पे जो पॉइंट में हम लोग जो टेंजेंट ड्रॉ किया, दिस लाइन इज द टेंजेंट लाइन and this is the average line and this should be the parallel with each other. So this, तो पैरेलल होगा तभी इसका जो एंगल है, एंगल सेम होगा ना. सो दिस एवरेज डिस्प्लेसमेंट और एवरेज वेलोसिटी लाइन विथ parallel this instantaneous velocity line. So this instantaneous velocity means this tangent of this point. So ये point कहाँ पे है, ये point है यहाँ पे. So यहाँ पे 20 second, this is the 10 second, so this is the 16 second. Okay, so now, so we can say this instantaneous velocity means this v means limit delta x by delta t, and this function of time tends to 0. So we can say this is dx by dt, or we can say here this is a ds by dt. This is a nothing but a slope. Okay, so thank you. I think everyone can understand this instantaneous velocity.